All right, welcome. I'm going to try a live stream here quickly, talking about Selenium and Python, how we can create WebDriver instances, close down the browser, handle existing chromedriver, and if something happens and the test doesn't complete cleanly, how it doesn't shut down the driver. It may leave a browser running or leave a chromedriver executable instance running, or if the browser crashes and leaves chromedriver server running. There are some things we can do to avoid that. We're going to talk about using try-catch blocks, using setup and teardown methods in Unittest, using Pi Test Fixtures to handle starting and stopping our browser cleanly, and lastly, we're going to talk about how we can do it on our own when we're not using a test framework. We'll use the Python context manager decorator to create and destroy our browser instances. So without further ado, let's go ahead and get started. So I'm going to go ahead and open up a browser window. Make sure that's coming on screen. Hopefully this is working all right. I don't know if the live stream will work, but here we go. I'm going to go to a directory I've created, handling WebDriver. You can see it has a virtual environment set up with PyEnv virtual environment. So I've got this handling Python virtual environment, and it's got Python 3.9.7. And what I want to do first, let's start off by creating. I like to use a virtual environment and then use pipenv to install my dependencies because it creates a pip file and a pip file lock. So I'm going to do pipenv install Selenium, and it's already here just to save some time, but it'll go through the motions and add it to my pip file.lock. And I will just check the chat. All right, and check the stream health, all those little things. Video resolution is 852 by 480. That's not right. Stream settings. It looks okay, but all right, we will go ahead and jump into this. I've got my environment set up, so let's just start with the simplest possible thing. I'm going to demonstrate some ways that Selenium can break down. So I'm just going to use IPython here to launch an interactive shell, and I can just do from Selenium import WebDriver. And to start off, I'm just going to do create a new instance of Chrome, right? So I'll do WebDriver.chrome. It'll launch my Chrome browser. It's off screen. I need to drag it on screen so you can see it here. And I can, I can't interact with my browser actually because I forgot to assign it to a variable. So if I just hop on over here, I'm going to create another terminal and I'm going to kill my browser. So I'm just going to grep chromedriver. So you can see here we've got a whole bunch of instances of Chrome, and if I want to be specific to chromedriver, I get that one, and I also get my grep command in my grep output. One way to get rid of that is I can do pipe it through grep-v, which means exclude grep. Now I'll only get my chromedriver instance, but there's also a little trick we can use with a regex to look for only something with C for chromedriver. So this is the pattern I'm going to go forward. I'm doing PS and I grep, and then in brackets I just put the first letter of chromedriver. so that we don't get it. And I can do the same thing for Chrome as well. So I get that. You see we've got all these different processes running for Chrome, right? Even though we've got a single Chrome browser window running. We've got Chrome renderer, 2 of those, 2 utilities, some zygotes, crash pad handler. I don't know what the zygote process does. Anyway, and then we've got our Chrome driver. So what I can do is I can just do kill. Here, I just want to kill Chrome driver at this time. So I'm going to get my process ID. That's this first variable here in ps-ef. That second column. First column is the user. So the username is Aaron. Process ID, parent process ID. That would be the IPython shell, I believe. I'm not sure what that is. I could get ahead. So still don't know what that is. And then the time that it starts, the terminal that it's starting on, the time it's been executing, and the command line. So looking at Chrome driver and comparing it to this here. Anyway, so I can just kill -9, not kill -8, 25995, and that kills my Chrome driver instance. So when I look at that, you can see I've got a Chrome driver that's defunct. The process has been killed, but the parent process ID still has a handle on it. But we don't have access. What can I do? Well, here's one little trick. If you call a function that returns a variable, that variable will be in the default variable name, which is underscore. I think in Perl it might be $_. And Python got it from that. So anyway, so I can say driver equals underscore, right? And if I try to do underscore.get or driver.get, and I'll just go to my blog, because this is going to be based on my most recent blog post. And we can see we get a timeout exceeded because while Chrome still exists, my Chrome driver instance has been killed off. So we can't interact with Chrome because Chrome driver is dead. This session ID that I have for my driver is no longer valid. So what can we do? Well, I can just kill off Chrome here just by clicking the X, right? And then I can see my Chrome driver is still defunct, and I also have well, I don't have any more Chrome processes running. But how do I get rid of that? Well, the easiest thing to do is I'll kill the parent process, the IPython, and then I go here, and you can see that defunct Chrome process is gone. So let's go back into IPython here. We'll hop ahead from Selenium, import WebDriver, and we'll do things the right way here. Driver equals WebDriver.Chrome, if I can type it. All right, it launches Chrome. We'll pull it on screen. Here, Chrome is being controlled by automated test software. That's Selenium WebDriver. So I can now interact with it, right? Driver.get fgaaron.wordpress.com, and it loads up my blog, which I just added a new theme and layout to. So this is the post I'm going to be talking about, using Python Context Manager Decorator to start and stop WebDriver. So if you want to look at that post as well, that'll give you some source code to look at for some of the things we're following along today. And I'll just paste this URL actually into the YouTube chat. Just for a historical record. Okay, well, we want to say, if we exit out of here, it's going to cleanly kill our Chrome driver instance and our Chrome process. Let's say we don't. Say we have a Chrome instance and we kill the Chrome instance, but our driver doesn't work. So now, when we try and get that, we're going to get Chrome not unreachable and this stack trace that shows up. And we can look in here and we can see we have a Chrome that's defunct and a Chrome driver that's still running. Again, the best way to take care of that is to exit out of your parent process. In this case, IPython, if I ran it from the shell or from a Python script, that would be the shell, the bash, or the Python version. And I can check again, and it says my Chrome driver is still running and my Chrome is defunct. Well, the problem here is now that I've killed the parent process, but Chrome driver isn't dead, I can kill -9 or I can kill all Chrome driver, see if that takes care of it. Or, yeah, that does take care of it. Or I could do kill -9 on the process ID. It's gone, so there's no point in trying that. Or there's some other things we could do from the command line to fix that up. But we don't want to have command line scripts or even, batch processes running around in the background to take care of that. Just for the record, if you are on Windows, I'll just bring another browser over here. If you are on Windows and the command to kill a Chrome driver process, for example, geckodriver, or the browser process, the IE driver, or whatever, or the IE driver server, any of these things, it's task kill and then -f or /f/im, and then whatever process you want to kill, chromedriver.exe /t to kill all Chrome driver processes. Again, on Linux or Mac, you can use kill all, or you can do this funky script I've got, ps-ef pipe through grep Chrome driver, and then use awk to get that second argument here, right? Let's see if I have an example of that. I don't, because I cleared it all. Well, I'll go ahead and start one up over here. Just so we can see it one more time, right? Chrome driver. All right, so there's our process ID. So we can kill all Chrome driver, or we can kill -9 the process ID, or we can use this, right? We can use this ps.ef script, pipe through Chrome driver, and then we can do awk print $2, because this is the first column. The second column is just a little awk shell scripting for you. So we can see we get our process ID right here, and then we can use that. We can pipe it through a program called xargs. -l will run it multiple times, and then we can do that. Well, let's just do echo kill -9, and then you can see what it does is if I had multiple Chrome driver instances, so I can actually simulate here. So now you can see I have 2 Chrome driver instances running. I can print both of them, and you can see I'm just echoing, but xargs says take the arguments, the output from the last command, which is the awk command. So take the output from awk and xargs-l for each line, perform this command. So kill -9 and then the process ID. So we'll just remove the echo from here, and that killed all of my Chrome driver processes. Well, they're defunct. The reason they're defunct is because they've been killed, but the parent process that owns that handle on that, the IPython, is still around. We do that, and they're gone. Okay, so I've simulated dangling chromedriver or a dangling browser without a chromedriver instance. Remember, if I kill the chromedriver, then my automated browser, here's my automated browser. My automated browser exists, but the chromedriver instance doesn't. So I can do kill all chrome. That kills the browser. This isn't it. This is Brave browser that I just brought over from the other side. And so you can kill those processes. You can even create, as you can see, a script here that will kill everything for you. That's this one here. ps-ef through grep chromedriver through awk print $2 for the second argument, xargs-l kill-9. Whew! And you can even have that run every minute or something to clear up stray chromedriver or Chrome processes. But we don't want to do that. We don't want to leave dangling Chrome drivers. We don't want to leave dangling Chromes or Firefoxes or Safaris or Edges or IEs or goodness knows what else. So let's talk about what we can do to avoid having those dangling drivers. Well, the obvious thing to do, and this is 90% of the issues, is when you write a test, you forget to shut down your driver instance. So let's go ahead and, do I have Visual Studio Code? I do, but that's my notes. So I'm going to bring up Visual Studio Code in this directory, bring it over, and make it fit. All right. And so I'm going to start by writing a simple test, right? Simpletest.py, and let's see, I was having some trouble earlier with Visual Studio Code finding my virtual environment. So let's see, from Selenium, import WebDriver. And okay, it looks like it found it now, so I got that taken care of. And then right, we can do driver equals WebDriver.chrome. And we can do driver.title, we'll print it. Well, I guess in order to print the title, we need to go somewhere. So we'll do driver.get, and we'll just use my blog post, pg.wordpress.com. All right, simple test, save that. And now I can go over here and I can do Python simpletest.py. And we can see it brings up the blog with that latest post, and it's actually going to, it's hanging. WordPress is having trouble detecting that the page itself is loaded, but it'll eventually get there in like 100 years or something. I probably just shouldn't use, I'm trying to get everything aligned so that I can flip easily between them. There we go. It finally got my title for the page, and it closed down. But it didn't close the browser. Oh no, precious, it didn't. The browser is here. The script is done. Well, what do? We can do ps-ef through grep Chrome. Sure. Like so, and we've got all these Chrome processes, right? We can kill all Chrome. Ow! That's a pain, right? There we go. That took care of it. What went wrong? Well, in this case, like I said, 90% of the time, what happens is your test executes cleanly. You just forgot to include the simple driver.quit statement. Now, if we run this, let's first make sure, all right, we've got a defunct Chrome, but we've got an existing Chrome driver. That's interesting. Is that because of this process? So let's go ahead and close that terminal, open a new one. Still there. I guess we need to kill our Chrome driver as well as our Chrome, and that should probably have taken care of both. Okay, so I needed to kill my Chrome, I needed to kill my Chrome driver, and now we're in a clean state again. But I didn't have that driver.quit. Now, whether you forget to put that driver.quit at the end of your test, or whether something happens throughout the execution of your test, some error happens, some uncaught exception, or some exception is raised, that you don't get to your driver quit statement. So we need to make sure that that happens. First, let's make sure that it works like this. Python simple test. It opens up, and here's the page. It's going to be annoying if it keeps opening off screen. Maybe I'll have to switch the default window. And again, it's taking a while. It's not printing the page. There we go. It eventually got there. All right, I'm going to stop using that URL. I'm going to, and I'll switch to oneshore.com. Now we can do this, and now we'll actually from time import sleep, because now it's going to go so fast. That I need that 3-second pause. It immediately prints the title, and then I've got 3 seconds. Let me see if I can leave a Chrome open. Tell Ubuntu which desktop to launch Chrome on. It's not going to do it. All right, give me a minute to work some shenanigans in the background. Create new folder. Don't kill OBS. Call it cleanup. Delete some stuff. Alright, and then I need to go to my displays. Not on a Mac. I'm going to set this as primary display. Apply. Keep this configuration and close that. Now, when I run simple test, yay, it opens Chrome in the same window. And we have our desktop displayed, which is a little bit annoying, but not too bad. All right, so I guess we need to bring that up still again. At least not yet. What do we want to do? We want to make sure that that this driver quit happens. So, for instance, if we driver dot find element that's missing, and we click on it, what's going to happen here? Let's move this sleep 3 down here. And we're going to run our test. Oh no, are we going to end up waiting 30 seconds for it to time out finding this element? We are. Let's count down. 1, 1,000, 2, 1,000, 3, 1,000. Oh man. While that's sitting there, let's driver dot implicitly wait 5 seconds. We're going to have another simulated failure here, buddy. We've got so it eventually did. So I've got this exception, right? Invalid argument, invalid locator. Well, it's not missing. There's no, right? For find element, you need a type. So I can buy CSS selector. But anyway, that did exactly what we wanted, right? We have Chrome still running, and I think chromedriver's dead though. Nope, chromedriver is not dead. So neither Chrome nor chromedriver died. Again, we need to kill all chromedriver, kill all Chrome, and now we're happy. Ish. Alright, so that just making sure that we have driver.quit isn't going to do what we need. And let's see if this so if that implicitly wait gives us a shorter pain period. Alright, so we're talking 1, 2, 3, 4, 5, and we should be here. Yeah, we've got our exception. That's much less painful of a wait period. I think it probably came up within 30 seconds. Anyway, we've got our invalid locator still. Oh, is it CSS selector? Let's just go ID. Who cares? One, 2, 3, 4, 5, and we see our exception. Well, now we've got a no such element. So any of these issues, right? Invalid selector, no such element, any WebDriver exception, or any other exception, file not found exception, network exceptions, all of these things can end up causing us a test that does not complete, does not call our driver quit. Well, first thing we can do is we can create a try except block, right? Except WebDriver exception. And then we can do something like print E. Is there an E.mem? I'll just do print E. Who cares? We're not going to handle it. And then finally, so what we're saying is, hey, whether this block, this try block succeeds, or whether we raise an exception, finally call driver.quit at the end. That's assuming that driver actually exists. We could check that our driver is not none or something like that here in case WebDriver Chrome failed, but it'll probably stop before, in this case it will stop before that. So we also need to import our WebDriver exception. So from selenium.common import WebDriver common.exceptions, there we go, import WebDriver exception. Alright, so that satisfies that. I'm going to do a little bit of cleanup here by moving this ahead. I just want my common imports, my standard library imports to be before my package imports. All right, so here's our code. We are now trying, and when we get an exception, we clean up after ourselves. So that's all well and good. 1, 2, 3, 4, 5. I was talking a little fast because I was a little slow getting to it. And we get our error. And it cleans up after ourselves. It looks like we've still got some Chrome dangling from previous runs. So, right, I can go kill these process manually. And so we've got some defunct Chromes with some WebDriver, so I need to kill all Chrome driver as well. Now we're clean again. So let's try this one more time. Python simpletest.py. We're going to in 5, 4, 3, 2, 1, throw an exception. No such element. And we wait 3 seconds and we clean up after ourselves. Both our Chrome and our Chrome driver instance are clear with the ps-ef. We're checking that. Okay, cool. That's one thing we can do. But do we really want to wrap everything in a try catch or a try except finally block? It's doable. In our tests, we can do this another way. So let's talk about creating a unit test. So I'm going to borrow a browser again over here. I'll just launch Chrome. Brave didn't want to drag over because my screen sizes are wrong. So unit test Python. What we want to do is we want to look at setup and teardown, right? So I'm going to create another file, and I'm going to call it test with unit test.py. All right, import unit test. And it's been a while since I've used this, so I need to look. Oh yeah, extends unit test test case. Class, we'll call it simple test. Extends or passes into the class argument the unit test.test case, and then we need a def. Now, I believe with unit tests you're not supposed to use init, or maybe that's in Python. No, you can use init, the init underscore magic function with a unit test class, but you cannot with a Pytest test class, I think. Anyway, so we've got setup and teardown, right? And you can see here, well, let's start with a test one short, right? We'll pass in self here. And we can do driver equals WebDriver dot Chrome, and then we can do driver dot get oneshore.com, and then we can do print driver dot title, assuming that it works, and then we can do driver dot quit. And then we can say Python test with unit test. Actually, it's been so long I don't remember how to run the test. Oh, Oh, you do Python-m for module. Here, we will change this to just for consistency. No? No. Python-m Unittest. Ran 0 tests. Let's look at, it has to start with test, huh? Ran 0 tests. Import unit test class. Starts with test. Def test. Underscore. I don't know why it's not detecting it. Class, test, capital T, right? Unit test case. Oh, the file name also has to be test. Now we're cooking. Nope. Now we're hosed. Now we're fried. Yay! We got one test and it failed. WebDriver is not defined. Well. From Selenium, import WebDriver. Alright, we got our test. It closes. We introduce by ID. That's not going to be found. And we run into the same problem. It will launch our browser and it completes. We've got, well, that's our documentation. Okay, so it succeeded. Oh, because we didn't try clicking on it. Alright, nothing's running. There we go. It runs and it still closed it down. But, alright, so I'm not able to duplicate the problem that I want to experience. So I want to do, let's assume we're running into a problem. Maybe we're doing this, right? I'm just trying to trigger an exception that will leave it hanging. So it's doing a good job of cleaning up after itself. What if I just Alright, so Unittest is cleaning up after itself on exceptions. But what I want to do is show you that you can have a setup method, and maybe this will get us there. Put that into self. And it's okay. Name driver is not defined. Oh. Resource warning, enable. Fix spot. So Unittest is doing a good job of cleaning up after itself. But we can be specific here, and we can explicitly tear down driver, self.driver, and we won't get any errors here. So Unittest does a good job of cleaning up after itself any dangling chromedriver instances, but Pytest won't necessarily do that, right? So I'm going to do test with Pytest. And I'm going to say import Pytest. And I'm just going to def test one short here. There we go. And driver.get sure.com. No module named Pytest. Alright, I should do pip m to install Pytest. It looks like I'm going to have to go, so I'm going to get really quick and show you how to get this running with maybe less commentary and maybe fewer mistakes. Alright, finally got Pytest installed. Is that one not implicitly waiting? Alright, so it ran the unit test and the Pi test. And test with Pytest. Okay, we want to let's do that, right? I didn't want to run them both. 3. That's the really confusing part here. But it's cleaning up even though we're running into this error. Alright, so what I wanted to show really quickly is how to use a Pi Test Fixture. Right? Well, I can create a driver instance. So what I want to do is I want to move my driver out of there. So I'm going to create a @pytest.fixture, and then I'm going to yield my driver, and I'm going to driver.quit. And now I'm going to Pytest-v for verbose, and then S for standard output. Test with Pytest, so that I'm not running every test. Function has no attribute get. And then I can pass in my driver fixture as an argument to my test, and it will yield. So this is just like, well, it's not just like, similar to a return, yield will pass this into here. It will pass this driver instance into the argument. So this is not the driver object, this is the driver function. And now this Pi Test Fixture is decorating this function, and it allows Pytest to know how to find it. So it passes in this function. This function is executed, and then it yields the driver to execute here. When this scope completes, the scope of the test completes, it returns. So yield is like a return, but it returns back after that scope is complete. And so it will then take care of the driver.quit. And now we can run our test in Pytest, and it will take care of the creation as well as the start and stop. Now, say we wanted to use different drivers, right? We wanted to use a remote WebDriver. We need to pass in two things, right? We need the command executor, and this could be either our Chrome driver, or I'm going to pass in my Selenium Server, assuming that it's working. And then we also need to pass in desired capabilities. And in this case, the desired capabilities is a dictionary with and all we really need is browser name, and that would be Chrome or Firefox or whatever, Safari. And then I need to make sure that my Selenium Server is running. I'll just create a new window. In this window, oh, it created it off screen, so we're going to have some pain. And I can see at localhost 4444, I don't have my Selenium Server running. So brew services start Selenium Server. And I think in this case, when I run brew, it doesn't detect Firefox, and I'll have to manually do it. Hit refresh 100 times on here. Successfully started. Oh, this must be like a WB. Nope. Okay, it was just behind schedule here. Okay, so this is Selenium Server or Selenium Grid 4.0. It has a different user interface, and you can see, yeah, it only shows my Chrome driver. So I'm going to brew services stop. Homebrew is a Mac utility that has been ported to Linux, and it works fairly well. But in this case, it's not detecting my geckodriver because it doesn't know how to find the path. So we've got this here, and got this here. So now we've got Chrome driver. and we've got Firefox or geckodriver. And you can see here the desired capabilities are both browser name and platform name. It'll take the default platform, or it'll take any platform if you specify, or if you don't specify one. So this is a good start. I'm just going to move all this here. We've got our remote WebDriver, we've got our command executor, we've got our desired capabilities, and all that gets pushed off. Downside here is, well, we've got to get some configuration if we want to change this, right? I mean, I can go into my configuration. I can say Firefox, and that should work. And here, I'm actually going to kill that off here. I'm going to start Selenium Server over there because I have my command history here, and I want to go back to here. Pytest start, and desired capabilities has been deprecated. Oh, well, the HTTPS is not correct. It should be HTTP. I don't remember changing that. Maybe I don't remember running it. Here's my Selenium grid. Okay, I've got one session running, and it should be a Firefox session, right? It's too slow. Oh, here comes Firefox up. Click here, sessions. There are no running or queued. Okay, so it's there. I'm going to, maybe I'll keep that around for a minute. Oh, there we go. Now we've got our session. It's just lagging a little bit. Anyway, you saw the Firefox session come up behind the screen. I'll do it one more time. Firefox loads really slow, especially on this older system. I've actually seen a lot of like either hanging or swapping going on with this computer. It's an older computer, but it has 8 gigs of RAM, quad-core i7. It's about 8, 9, 10 years old. But it's running Ubuntu 18 or Linux Mint. So it shouldn't be running into those sorts of issues. I'm wondering if the user interface on Linux is just terrible anymore. Or maybe it's improved. Anyway, I need to upgrade this to like Ubuntu 20 eventually. If I can get this grid to be small enough to fit on this small screen for YouTube. Alright, so I'm just going to tuck that grid away into the background. We've got a warning. Please pass an options object. So, I'm not going to worry about that now. Pretend we're using Selenium 3 still, and we pass options, and we pass Chrome options or Firefox options or whatever. So this is how you can do it with a Pi Test Fixture. Now, anything that happens in a test is going to be outside our test, outside our setup and teardown with Unittest. This fixture is going to, whatever happens in this test, whether it raises an exception, or not, whatever it does, that fixture is handling the starting and stopping of my browser. I need to switch that back to Chrome. And it can also, within the fixture, it can actually have another fixture. So I can have a separate fixture that and this could hypothetically read from a YAML file or something, right? Actually, I don't think I need to do that, right? I can just do... looks like I need to pip install YAML. Pi YAML. Pip env install. It's not detecting my virtual environment. I'll give it one more try. Now it should need Pytest, PyYAML, and Selenium. I think that's all. While that's looking, we'll look at what it's saying. Oh, this is our Chrome driver. Or our Selenium Server. Yep, so we've got Selenium, Pytest, and PyYAML. And it went ahead and installed those. So now I'm going to try to see if Visual Studio Code detects my virtual environment and is happy with that. It looks like it is so far. Maybe it'll just take a minute for it to catch up. Discovering Python interpreters, yes. And then it'll probably choke. It's not showing it. Configure Python language base settings. All right, I could use some help on getting this. I did something or it just finally caught up. But on my Mac, I see my virtual environment and I can choose my virtual environment. For some reason, it's not doing that. All right. So, jumping ahead, we're probably going to have to skip that. All right, config.yml. And then we can do something like browser, we'll do browser name equals Chrome, and we'll make that a comment. And and then in this case, we can just return config because we don't need to yield back to this. Okay, config, and then we can pass in that fixture. I'm going to print my config to see what's going on, and something like that. We'll see if that works. Pytest, test with Pytest, so we don't run into our other test. All right. I'm going to have to look at the documentation. Load stream loader dumper. What? Alright, let's hop into IPython. Curious, are they doing import YAML? Okay. Here's my config file. Pi YAML load from file. I'm wondering if this with libyaml is the issue. Oh, I need like R for read write. That should be default. Okay, so I need to open the file. All right, with open. Equals still missing that. Control Shift in Linux. Let's see. All right, so let's try safe load. There we go. We just needed safe load. Curious if we do need to load it as a file. Let's test it out. No. Okay, so we do need that. Okay, okay, so back to our config. With open config.yml as file. Safe load. File, there we go. Let's see if that works. Okay, we've got an error. Config is browser name. Config equals Now let's move this debugging up here. I'm doing something wrong. I must have the wrong format for YAML. Is it a colon? It is just a colon, okay. Where's my config dot? Okay, so I need browser name, Chrome, and I think quotes are optional. We'll see. I should have just used an environment variable. Alright, it's opening Chrome. Yeah. So then I hop on over here. I change my browser name from Chrome to Firefox. And we've got our exception. For you Animaniacs fans out there. Now, by just changing the config file, it should open Firefox, and my Pi Test Fixture handles all of that. There we go. We've got Firefox opening. Slowly. There we go. All right. Lesson 1, don't use Firefox. Lesson 2, don't use WordPress. Lesson 3, don't use Linux. Lesson 4, don't use Selenium 4. All right, so the last, we figured out how to use a YAML file for configuring. The last thing I want to show you how to do is to use the this is really the whole point, the context manager, right? What if we are not testing in a test? What if we don't have Pytest or Unittest or something? We just run our simple test, and we don't want to put it in a try except box. So what we can do is we can using context manager, and I'm really killing myself for not taking the time to show this, but I wanted this to be the focus of today's demonstration. But so just search for Python context manager. You can see I've done so recently, and it's this contextlib, right? This contextlib library. From contextlib, import context manager. And then we have the context manager decorator. Remember, the decorator takes your function as an argument, it modifies it, and in this case, it's returning a generator function so that you can then yield your resource. So just like in the Pi Test Fixture, I can yield a driver instance and have it configured outside of my test and make sure that function both handles the setup and the teardown of my driver instance. So from contextlib, import context manager. And then I can use the context manager decorator, right, to create a function, and I'll just call this browser. And we can do driver equals WebDriver. Well, we need from Selenium import WebDriver. WebDriver.remote, and you can see in here the options are to pass the args and the quargs in here, right? But I could just pass in the driver. I don't think I can do that. Let's see. We'll just say driver equals chrome, and we'll also say URL equals HTTP colon localhost 4444. So we're making assumptions here that can be overridden. And then we need our command executor is the URL, and our driver is our desired capabilities equals browser name colon driver. Actually, we should just call this browser. And let's get this all on one line. Yeah, that works. Okay. So let's change our bit around here. Right, so make this all visible. So we decorate our function. This looks just like our fixture. I mean, it looks much like our fixture in that we will yield, right? So what we want to do is we want to put our try catch block in here, right? We want to try to yield driver, and then we can handle exceptions, but I'm actually not going to do that here. I'm just going to finally driver.quit. So the idea is here we yield our driver and then finally we quit, just like it said in the code. You acquire your resource, you yield your resource. The resource that we're getting, the context that we're getting, is a driver instance, and then you try to execute it. So anything in our function that we're going to execute, we are then going to be able to catch anything that throws and handle the finally quit in here. And now this doesn't work like a decorator, or it doesn't work like a fixture so much as it works like that opening the file handle, right? Or here we go. Let's take a look at our Pytest test, right? So we're using our config.yaml here. Here we go. In our test with Pytest, we created a fixture that creates our WebDriver instance, right? This looks very similar to what we've got right here. But this also takes the config fixture. Our config fixture, well, it reads the YAML file, and this is this common thing you see with open file as file. So now in our using context manager, we've got this this generator function, well, it's not a generator. I don't think it's a generator, but it works similar to a generator in that you can yield the result. It's only yielding the driver once. But now I can say with driver as, we'll call it as browser, just to distinguish it. And then we can do browser.get and it will handle the quit. So we can then import this, right? We can make this as an external library. And actually, let's do that. Well, let's test it out and then we'll do that later. Now we can just do Python using Context Manager. Where are we going wrong? Line 15. Oh, we need to call it as a function here. Alright, deprecation warning, we're cool there, at least as far as that goes. Okay, it's opening slowly. I don't know why it's hanging on the output there. And I used the blog. Anyway, this is the blog post using Python Context Manager Decorators start and stop WebDriver. And we didn't even print the title, right? But anyway, so let's take it to the next level. We can actually, we can use our config and everything, but rather than passing in the browser and the URL here, well, we could pass it in, right? We could say browser equals Firefox. And we're still going to get that warning from our remote WebDriver. But eventually, now in our test code, we can just we can pass in our browser as an option there. And we can see it opens up, and it's going to take a million years for the browser to get to it. Firefox is even slower than Chrome on this computer. That's another thing I've noticed is actually launching drivers on Selenium 4 is pretty slow, at least on Linux. Both Chrome and Firefox launch really slow with Selenium 4, so another good reason to use Selenium 3. Anyway, so that's all I've got for today. I'm going to go ahead and wrap it up. We'll check to see any messages. Okay, no messages. Anyway, the blog post is in the chat as well. So take care, everyone. Have a good night, and hopefully this posts to YouTube okay. Goodbye.